Okay, here is lab 21, part 3.3. We are building our own CMOS NAND gate out of individual MOSFETs, two P-channel MOSFETs, and two N-channel MOSFETs. So we have 5 volts, which is going to the source of the first P-channel MOSFET. It's also going to the source of the second P-channel MOSFET. And then we have ground down here that's going to the source of the second N-channel MOSFET. And then the drain of that second N-channel MOSFET is going to the source of the first N-channel MOSFET. And the drain of that N-channel MOSFET is going to the drain of both of these P-channel MOSFETs. Then input A goes to the gate of P1 and to the gate of N1. Input B goes to the gate of P2 and also to the gate of N2. And what you'll find if you trace through all of the possibilities, remember that the N-channel MOSFETs are like closed switches. They're on, they conduct if the input is high, and they're open, so they don't conduct if the input is low, and the opposite is true of the P-channel MOSFETs. So they conduct if the input is low, and they do not conduct if the input is high. So if you work that out, you'll see that in 3 of the 4 cases of the 2 input combinations, the output will be high. In other words, there will be a low impedance path from the output to +5. And in the 4th case, where both inputs are high, you will see that there is a low impedance path to ground, so the output will be low. So we'll see that in a minute. To display the output, so that the output goes to these 2 drains, it also goes to this drain. So to see that happen, I have a 100 ohm resistor and a red LED to ground. And then to stimulate the inputs, I use the same trick we used at the beginning of this lab with the 14-pin dip package. So here's +5 volts going to one side of a switch. The other side of the switch goes through 100 ohms to ground. So then if you look at the top of this 100 ohm resistor, if you're not pushing the button, then you get ground through 100 ohms. If you are pushing the button, you get +5 because a 0 ohm connection to +5 beats a 100 ohm connection to ground. And then same story down here. So you have one button for input A, one button for input B. Remember, ground, gate, drain, source. Gate, drain, source, if you can hold this so that you see the writing. On my breadboard, I laid out P1, then P2, then N1, then N2, and they're all, none of them are backwards. So we have, so you can see the writing on all of them. P1, P2, N1, N2. And then here's my first button. So it's going to the gate of P1, and it's also jumping across to the gate of N1. There's the second button, it's going to the gate of P2, it's also jumping across to the gate of N2. And then from the drain of P2, which also turns out to be the drain of P1, and it also turns out to be the drain of N1, I'll go through a 100 ohm resistor through this LED to ground. So I have +5 up here, I have ground down here, and then the other things are wired up as described on the circuit diagram. I guess I can try to give you a top view there for a moment. Okay, so then let's see it work. So if I push, so they're both low, both inputs are low. Input A goes high, nothing happens. Input B goes high, nothing happens. Inputs A and B both go high. Ha! The LED goes off, so that is the NAND function. Low, low is on. High, low, low, high, they're both on. But high, high, it's off. So there is my homemade CMOS NAND gate made from 4 MOSFETs, 2 p-channel MOSFETs and 2 n-channel MOSFETs.